Hey, hello. This is Advanced Algebra 2. These are the answers for the day 1 activity. Have some stuff worked out here for you. It's meant to be helpful. I really welcome any feedback you might have about if this was helpful for you or not as we work through it. Hey, let's get started. I'm going to do number 1 here for you first. Now we're simplifying. So 2x plus 3x. Notice that they're like terms. It combines. 5x. Done. Bam. All right, now let's look at the next one. 2x plus 3. And 2x is great, but 3 doesn't have an x, so they're not like terms. So in terms of an answer, it's just 2x plus 3. All right, the next one. First one to distribute, or rainbow out the 2. Then notice you got some like terms going on with the 2x and the other 2x. Also like terms with the 6 and the 3. Adds up, makes 4x plus 9. Let's look at number 4. The 2x distributes. And the trick there is that makes that 2x squared on the first term. And then the x's have different powers or different exponents on them. So that makes them not like terms. As a result, the answer is 2x squared plus 6x. The two terms themselves don't combine nicely with addition. Hey, let's move on. Number 5 here. The 2 distributes. And then the negative 4 distributes. Notice that you need to take the negative 4, distribute that with a negative sign. Then we got some like terms with the 2x and the negative 4x. The 6 and the negative 8. We're talking about negative 2x minus 2. All right, number 6. Likewise, some distribution happening. Negative 4, again, distributing on that right half. Again, like terms. Like terms again for the 6 and the 8. And it's negative 2x plus 14. Boom, boom. The trick on number 6 is to notice that negative 4 multiplied with negative 2 on the right bit to make positive 8. Okay, that's it for the first page. Let's look at the second page, problems. Here we've got some equations to solve. Nothing terribly exciting, but we're going to subtract 3, then divide by 2. You get 5 halves. Now, if you prefer a decimal version, 2.5 is fine. If you prefer mixed numbers, 2 and a half is fine. I'm going to kind of expect you to be able to notice, that 5 halves is the same as 2.5, and that, hey, you got it right, that sort of thing. But you can always ask me if you're unsure. Let's look at number 8. The 2 will need to distribute first before you can play equation solving games. Then you get started by subtracting 6, dividing by 2, boom, bada boom, boom, x equals 1. All right, number 9. Let's begin by adding like terms. So 2x and 8x. Then we can go ahead and solve the equation. Boom, chicka boom, and you end up with 3/5. Again, if you prefer a decimal, you could have thrown down 0.6 is great. If you're going to write a fraction, I really need you to write it in lowest terms. At this point, you probably should just be using your calculator for fractions anyway, and they will reduce it for you automatically. All right, number 10. This time we have variables on both sides, so we'll subtract 8x, perhaps, first, then subtract the 3 to move it. And then after you're all done dividing and playing games, you get x equals negative 1. Okay, now I subtracted 8x first. If instead you were feeling more happy about subtracting 2x, your work would look a little different if you showed as much work, but you would have ended up with the same answer in the end. All right, let's go ahead and look at number 11. We got to do that distributive property first. Then combine your like terms, so 26x plus 27 equals 0. Don't get scared by the 0, you still got to move that 27 over. Then divide by 26. It's an obnoxious fraction. It's the way life goes sometimes. Boom, negative 27 over 26. Again, a mixed number version of negative 1 and 1/26 would have been fine. A decimal version is fine, however, in this case, it's probably going to be a repeating one, so to write it exactly correctly, you would need the repeating bar over the right digits. So if you don't know what that means, please ask me about it, or just don't write your answers as decimals. Hey, number 12. Distributive properties. Got a whole bunch of things going on here. So you got to take that 4x minus 8. And then don't forget about your other stuff. Then go ahead and combine like terms. So you got 2x plus 3. And then you got 2x plus 3. Subtract the 2x. Subtract the 2x. Boom. 3 equals 3. Hey, they're the same thing. Infinite solutions. That's it. All right. Now, that was all of page 2. Here's page 3. Now, here we've got absolute value equations. You should have some experience with these from before, but, this is review. We're expecting to need some help here. So, absolute value means you want to break that into two different equations. The thing equals the negative thing, or the thing equals the positive thing. I said thing a lot there. Hopefully the visual helps. So then you have two separate equations to solve. Writing or in between gives you bonus points. It makes you cool like me. That should be a long-term goal. All right, number 14, same deal. Take that 3x minus 9 and make it negative 6. Also, make it 6. Solve each of them separately. The solving part should not be terribly exciting after you've got started. Again, writing or, style points. Long term, we're going to have some other issues about how we write answers. But for now, writing or in between is the style issue. Hey, look at number 15. Now, in this case, that 2 was not part of the absolute value, so you're going to move that first. Then deal with the absolute value, which means a negative 4 version and a positive 4 version. Then go ahead and solve each one. So 5/3 is one answer, 13/3 is another. Again, or in between gives you style points. As I've said before, you could have gone with a mixed number version, 1 2/3 for the first one, 4 1/3 for the second one. Or you could have done decimals. Again, these have repeating decimals. You would need the bar in the right spot. It's a thing, but it would be fine too. Okay, number 16. Now here it's all packed up, so we're going to begin by unpacking it, moving the 3, because it's just hanging out there. But then also divide by 2, because that 2 is not part of the absolute value. The 2 is not really part of your problem. Now break it out. Remove the absolute value. Once for negative, once for positive, and then solve it each. And they're fractions, so it's tedious, but, either good memory of 7th grade or good calculator use will get you through here. As always, or at the end, gives you style points, makes you seem fly. Okay, I think that's it for page 3 here. Now, if we move on to page 4, we're talking about inequalities. Now, inequalities aren't crazy time, but there's a thing. You got to solve it. Boom. In this case, it was less than 3. So you draw an open dot at 3, and then line headed to the left, headed downhill. Now, number 18. You end up solving it. You get x is greater than or equal to negative 1. Boom. Because of the equal sign, it's a closed dot. And negative 1. And then headed uphill. You got happiness involved here. Okay. Let's look at number 19. Solving the inequality. Notice, of course, the sign flipped because we divided by a negative number. It's a tricky piece. Again, because of the or equal to bit. Go ahead and make a solid dot, and then headed downhill for 3. All right, moving on. Number 20, I moved the 2x, and then I flipped the whole thing around because it looked like the wrong order to me. And then divided by 8, boom, open dot at 3/8. Don't sweat too much about exactly where, 3/8, it's a little bit less than a half. So, boom, draw your open dot at a half-ish, and then left for less than. All right, that's it for page 4, I believe. Then page 5 was instruction, or examples. Page 6, here we got some problems. Now, absolute value inequalities are so much more interesting than the other stuff you had on that packet. So, less thans make what I call a little sandwich, where it's between negative 3 and 3, which is great. And then you subtract stuff from all 3 sides of the inequality all of a sudden. So you end up between negative 5 and 1. closed dot at -5, closed dot at 1, and little line in between them. That's great for less than. Number 22, by contrast, is a greater than. All of a sudden, different beast entirely. So, it breaks out into two things. X plus 2 is less than or equal to -3, or x plus 2 is greater than or equal to 3. Two separate inequalities. Moving forward, you solve each of them kind of separately on their own. They're actually not terribly exciting individually, but it gives you two answers. Boom. Less than or equal to -5, so a solid dot at -5. Boom. Headed left, because less than. And then, or x greater than or equal to 1, solid dot at 1, and then headed uphill with an arrow. Okay. Last two. Number 23, it's a greater than. So again, we're going to break this bad boy into two separate problems. One less than the negative version, and one greater than the positive version. Take a second and check that out. And then you go ahead and solve each of them separately. You subtract the 4, and then you divide by the 2, -19 halves. On the other one, you subtract the 4, and then you divide by 2, so you have 11 halves. Now this time, of course, it's or, as always, and you got a less than and a greater than, no or equal to, so you got open dots, and then arrows go in the way to match. Number 24, it's a less than, so like number 21, it's a little sandwich between -15 and 15, except that doesn't make sense because it can't be less than negative, so, no solution. Absolute values can't be less than 0. It can't be negative. That's crazy talk. Alright. Now, here's what I did, though. I pretended that I just wasn't thinking, and I just solved it anyway. So, less than -15 would mean it's stuck between 15 and -15, kind of the opposite version on both sides. Same problem. You subtract 4, you're feeling good about life. And then you divide by 2. All three sides, as always. It's kind of fun times. And then you're stuck between 11 halves and -19 halves. And that's crazy talk, because you can't be above 11 halves and also below -19 halves at the same time. You can't be more than 5.5 and also less than -9.5 at the same time. Don't even try. Okay, hey, look. These were meant to be helpful explanations of the thing we went over in class as a bunch of review kind of things to get started for the school year. All right. Let me know if this was helpful. Let me know if this was not helpful. Or just don't let me know anything. But please don't hesitate to let me know if you have any questions. Thank you for watching.